So for our last conic section, we will now have hyperbola. Imagine the times when the GPS system was not yet created. Looking for a place was quite difficult, even with the use of maps. Moreover, imagine the difficulty of locating a moving object. However, the GPS predecessor called the LORAN, or Long Range Navigation System, was used to transmit radio signals which are analyzed in order to determine the distances between certain locations. All this use the concept of hyperbola in calculating time and distances. When we say hyperbola, this is a locus or set of all points xy in a plane which the difference of whose distances from two fixed points f1 and f2 is constant. Again, these two fixed points are the foci, plural form of focus. Okay. Now, focus of the hyperbola. Let me correct that. Now, if you remember, for ellipse, we use the sum of distances. This time, we have the difference of the distances. So, as you can see, uh, we might be having almost the same, okay? Almost the same parts, almost the same equation, but of course, from the term itself, we will not be adding anymore. We will now be using subtraction. So let me give you a view of a hyperbola. If you remember ellipse, okay, they are like two parabolas, okay, connected, right? Kaya meron tayong elongated round shape. But in hyperbola, you have actually two parabolas then, okay? But this time, they are going towards on the other side. Parang hindi sila bate. Magkatalikod sila. Yung ganon. Okay? So, let us have the parts. We still have the foci, focus 1 and focus 2. Okay? But we have still the vertex, but we no longer have two we no longer have co-vertex. We only have the vertices. Okay, we have two vertices, and then this vertices, okay, will now have or will now be denoted by A. But we take note that we call this the transverse axis. Again, the line connecting the two vertices is called the transverse axis. Remember, sa ellipse, we call them major axis, minor axis. Pagdating po sa hyperbola, we call them transverse axis. Now, the distance from the center to the focus is C. Ayan, medyo mag-iiba na. Kasi dati, pag meron tayo A squared, B squared. Pero, pareho pa rin siya na ang C ngayon ay para sa focus pa din. Okay? Ang vertex ay para sa A pa din. Pero wala tayong co-vertex. Okay? So we have two branches. We have branch 1 and branch 2. That is for the two parabolas that comprises or that makes the parabola. And then we have the conjugate axis. Now, the conjugate axis is actually the axis which is perpendicular, okay, or that passes through the transverse axis. So if your transverse axis is lying on the x-axis, then your conjugate axis will now be lying on the y-axis. So I still have to reiterate this, that the center that we'll be using will still be the origin. Okay? And then you see the black lines here, we call this the asymptotes. What are these asymptotes? Asymptotes are actually imaginary lines wherein your hyperbola draws near, okay, as they go longer, it goes nearer the asymptote, pero it will never touch, it will never go through the asymptote. Again, it goes nearer as it goes longer, it goes near the asymptote, but it will never meet or touch the asymptote. For the standard form of equation of a hyperbola with vertex at the origin, we now have x squared over a squared minus y squared over b squared equals 1. So as you can see, we now have a different operation used. And this is already negative. So, hindi siya masyadong nalalayo talaga. Kasi po, may x squared over a squared pa rin tayo, y squared over b squared, pero ang gamit natin ay negative. Okay? So, we still have a and b, the vertices and co-vertices. Now, let's see how are we going to have the cases of the hyperbola. Case 1, hyperbola horizontal. So we still see these parts. We use A1 and A2 for the vertices this time, but actually we can still be using V1, V2. Anyway, it's the same. Okay, next, we still have B. Look at B. Now, I want you to focus on this one. You see, meron pa rin pala si B, pero hindi siya kasama sa main parts ni hyperbola. Instead, okay, this actually, quadrilateral that you see here will now be a pattern or pwede nating guide para sa pagkuha ng asymptotes natin in a while. So, we see focus, C pa rin siya. Vertices, A pa rin po. Co-vertices, B pa rin po. But we don't use them as V and CV anymore because B here is no longer a vertex. Okay? It will now be just part of the guide for us to identify our asymptote in a while. So look, the green line. So I have made diagonals, okay, inside the quadrilateral, but I have extended it outside until it would reach the hyperbola, okay? So this will now be our guide in creating our asymptote. So magagamit pa rin si B, pero hindi na po siya co-vertex ngayon. So transverse axis is along the x-axis. Conjugate axis is along the y-axis. And again, we have the other parts. Now, you might be asking, Ma'am, is it possible for us to have an A value which is less than B value? We'll see in a while. So we have here x squared over a squared minus y squared over b squared equals 1. Transverse at the x-axis, conjugate at the y-axis. Foci, positive negative C0. Vertices, positive negative A0. And asymptotes now will have an equation of y is equal to positive negative b over ax. And again, what do you call this? Your C will now be determined by square root of a squared plus b squared. B here is identified, yet it's not a major part of the hyperbola. But again, we still be needing it for us to guide us for our asymptote. Okay, let's go to the second case. So we again have the transverse. Okay, we still have the transverse axis, but this time it is along the y-axis. And then our conjugate axis is along the x-axis. Okay, so we still have A, B, and C. Now, for our equations and conditions, you look at this one. Okay, you now have y squared over e squared minus x squared over b squared. Kasi sa ellipse, what we usually switch is the position of a squared and b squared, right? But this time, we switch on the equation wherein ang nagpapalit ay si y squared at saka si x squared. Okay? So, anong ibig sabihin nito? We look after the positive and the negative term. Okay? The positive term is where our transverse axis lie. So if you have positive y squared, that means your transverse axis is along the y-axis. Okay? And the negative term, which is x squared, negative x squared, that means your conjugate is at the x-axis. Now, let me go back, okay, to the previous case. Look at this one. You have x squared over a squared minus y squared over b squared. So it means that since you have a positive x squared, it means your transverse axis is along the x-axis. Negative y squared conjugate is along the y-axis. Okay? And then, comparing it with the next one, the foci is already a y-intercept, even the vertices, okay? Asymptote now will have an equation, positive, negative, a over b x. It is no longer b over a. Kasi nga po, nagkapalit na po yung posisyon ni y squared at saka ni x squared. And then for c, it would still be square root of a squared plus b squared. Take note ha, si ellipse, ang ginagamit niya is a squared minus b squared. Si hyperbola, it is square root of a squared plus b squared. Okay. So the question here is it possible for us to have a value or a value b which is greater than a? Yes, it is possible. So posible pong mataas si b kesa si a, kesa kay a. Okay. So this is now our cases. We have case 1, case 2. This is the summary. So I would like you to take note of this. We will still be using covertices para hindi po tayo malito, okay? Pero gagamitin natin A and B. Okay? Tapos, we will still be using B for the covertices. Again, foci and vertices will have the same intercept. So, kung si foci ay nasa x, si vertex ay nasa x din. Kung si foci ay nasa y, then si vertex ay nasa y din. Then, si covertex po ay naka-reverse. So, let us have the first example. So, it says, find the parts and sketch the hyperbola. So, you have 4x squared minus y squared equals 16. So, katulad lang po ni ellipse, di ba, ang goal natin, dapat mag-negative, mag 1 po yung right side. So, we just have to divide the whole equation by 16 to make this one. So, we simplify. This will become 4. So, you're going to have x squared over 4 minus y squared over 16 equals 1. Okay. First question, do we have case 1 or case 2? Horizontal or vertical? Okay. So, as you can see, you have positive x, negative y. Dahil positive x at negative y, it means that our transverse axis is at the x-axis and the conjugate axis is at the or along the y-axis. And you see, di ba ito po dapat si A, tapos ito dapat si B. O, you see, B can now be greater than A. Okay? So, writing it down, A squared is equal to 4. Get the square root again to simplify it. So A is equal to 2. Then B squared is equal to 16. We get the square root again. So B is equal to 4. So we have A and B already. So let us now solve for C. Let us now have A squared plus B squared na po siya ngayon. So you have 4 plus 16. C is equal to the square root of 20. So this can be simplified as get the factors. So you have 4 times 5. So C is equal to 2 square root of 5. Okay? So since we have the values of A, B, and C, we may now have the parts of a hyperbola. Okay? So we start with the foci, F. We will now have positive, negative C. So you'll have positive, negative 2 square root of 5, 0. And then our vertices, again, we will be using A this time. So A, that is positive, negative 2, 0. Then B will be 0, positive, negative 4. Okay? Asymptote Y is equal to positive, negative B over A. That is 4 over 2. So we simplify 4 over 2. That is actually 2x. Okay? So this actually completes our parts. We may now be opening our Desmos for us to graph our given problem. So let us now have the graph of our equation. So we have x squared over 4. So x squared over 4 minus y squared over 16 space and then equals 1. Okay, so that is our hyperbola. So I'll make this a little smaller. So you'll be able to see the hyperbola. Oh, we're okay with this. Next, let us now have the parts. So for the foci, we have positive, negative 2 square root of 5. So you have 2 square root of 5, 0. Yeah, wait lang. Forgot to put space. 0. So this is F1. Then negative 2 square root of 5 space 0, and this will be F. And then let's have the vertices. We'll have A1 and A2. We have positive 2, 0. Let's have this as A1. And then negative 2, 0 for A2. And then we'll have B. So we have 0, positive, negative 4. So we start with positive 4. Let's have this as B1. And 0, negative 4 for B2. Okay. And for our asymptote, we have 2, right? So positive 2x and negative 2x. So you'll have y is equal to positive 2x there. And y equals negative 2x. Okay. That's it. We now have the sketch of our hyperbola. For our next example, we have here, find the parts and draw the graph of the hyperbola defined by the equation x squared minus 2y squared equals negative 8. Okay. So, kanina, we have on the right side a positive number. So, there's no problem with that. We just have to divide it with that certain number. Eh, ito negative. So, magdi-divide ba tayo ng negative? Yes. So, kailangan po natin i-divide yung ating equation by a negative number to make the right side positive 1. Okay? So, that means we have to divide each term by negative 8. Okay, so with that, you're going to have negative x squared over 8, negative, negative, so that becomes positive 2 over 8 is actually 1/4. So you have y squared over 4 equals negative 8 over negative 8 is positive 1. We can actually rewrite this into y squared over 4 minus x squared over 8 equals 1. Para you have positive term, negative term equals 1. Okay? So it's easier for us to now determine which is A and B. And then, next to that, we also know that you have a positive y term. That means we are at case 2, wherein our transverse axis is along the y-axis and our conjugate axis is along the x-axis. So let us now start by identifying A. A squared is 4, therefore A is equal to 2. We get the square root. Then B squared is equal to 8. So B is equal to 2 square root of 2. Okay, just to show you that, you'll have square root of 8, factor it out, you're going to have square root of 4 times 2. So square root of 2 square root of 2. Okay? Next. So we're going to identify C this time by adding A squared and B squared. So C is equal to 4 plus 8. So C is equal to the square root of 12. Again, we can simplify this one. We get the factors 4 and 3. So we actually have 2 square root of 3. Okay? So A is equal to 2, B is equal to 2 square root of 2, and C is equal to 2 square root of 3. So with that, we will now be identifying the parts. We'll now have the foci. We'll start with C. We'll now have 0 on the x-coordinate. Remember, our transverse axis is at the y-axis. We are at case 2. So you have 0, and then positive negative 2 square root of 3. Then A will now be 0, positive negative 2, and B will now be positive negative 2 square root of 2, 0. For the asymptote, we're now going to have y is equal to A over B this time. So y is equal to A, which is 2, over B, which is 2 square root of 2x. But take note, this is quite different because we have to rationalize. So you will multiply both numerator and denominator by square root of times square root of 2, square root of 2x. So we're going to have this part, y is equal to, we may cancel out this. And then we're going to have square root of 2 over 2. So positive negative square root of 2 over 2x. So we already have the parts. Let us now have the graph using Desmos. So for our graph, I already placed, okay, the equation and then the parts already, okay? So you have 0, 2 square root of 3, 0, negative 2 square root of 3, and so on. I'm going to just make this a little smaller so you'll be able to see it. And to complete it, let us now have the asymptote. The asymptote now will be y is equal to square root of 2. Then put space before you click on the negative sign. Okay. Divide by 2, then space again, then x. There. And the last one, y is equal to, we may just copy this one and then put negative sign. That will be easier. Okay, and then we have just please negative sign. Then that's it. We now have the graph of the hyperbola. Let us now have the solving applications for hyperbola. The reflection property of hyperbolas is very interesting. For example, light rays directed towards one of its foci will reflect all these rays to the other foci. This is utilized in various optical instruments. Further, it is identified
that there are heavenly bodies in our solar system that have hyperbolic orbits. It is noted that about 70 comets follow hyperbolic orbits. Hyperbola is also very unique in characteristics because it is the conic section which is also identified in non-Euclidean geometry. LoRa navigational transmitters A at -130 and B at +130 are positioned. A receiver P on a fishing boat located on the hyperbolic path listens to the transmissions of both A and B, thus being able to compute their difference in distance to be 240 kilometers. So here are the questions to be answered. Letter A. What values are given based on the problem? So we have to solve for A, B, and C. B, identify the coordinates of different essential points of the hyperbola. So we have to solve for the foci, vertex, and or the vertices and co-vertices. And the last one, we have to determine the standard form of equation of the hyperbola. So looking at the illustration given. So this is A, as shown here. This is one of the foci. Okay, A and B. So these are the foci of our hyperbola. Now, it is noted that P receives both transmissions coming from A and B. So with that, this P here lies on one of the branches of the hyperbolic path. Okay? And from that, it was able to determine that the distance between these hyperbolic paths is 240 kilometers. So for us to be able to see the whole picture, we may now have or we may now create hyperbola, okay, based from the given. So let us make our x and y axis. So let's say this is our y axis and this is our x axis. Okay. And then it is noted that A and B are the foci and they are 130 away from the center. So let's say this is A, which is -130, and this is B, which is +130. Now, from this given foci, we can actually conclude that our hyperbola opens to the left and to the right, or the transverse axis lies on the x-coordinate or x-axis. Okay, so we have the hyperbola here. Okay, and one of these branches actually is where the location of P or of the fishing boat. Okay, so from the given problem, it says that the distance, okay, of these two transmissions, okay, creating hyperbolic path is actually 240. The whole distance is 240. So if the whole distance is 240, then we can say that the distance from the center, okay, to one of the branches is 120. Okay? So why are we talking about just one part or half of it? We know that from the center going to one of the vertices will actually be the value of A. Okay? So from there, we may now say that A is equal to 120. Now, what else are we given with? The foci A and the foci A and B actually lies on positive and negative 130. So we know that foci is actually comprises the letter C. Therefore, C is equal to 130. So we already know the values of A and C. We may now identify the value of B by applying the formula. Sorry for this. The formula C is equal to the square root of A squared plus B squared. But this time, we're not looking for C since C is already identified. So we will substitute C, which is 130. Then we substitute A, which is 120, then square plus B squared, which is the unknown. Okay, So let us simplify. 130, or we may remove the square root symbol or the radical symbol first by getting the square of both sides. So we square both sides. 130 squared is equal to 16,900 equals 120 squared is 14,400 plus b squared. So we separate the variable from the constant. So we're going to have b squared is equal to 16,900 minus 14,400. So we subtract b squared is equal to 16,900 minus 14,400 is actually 2,500. So we get the square root of both sides for us to get the value of b. So square root, we may now have b equals 50. So with that, we can actually solve or answer letter A with all the values that we have. So A is equal to 120, B is equal to 50, and C is equal to 130. Now from here, we can actually solve for B and C already. So identifying the foci, which is the C value, so that becomes positive, negative, 130, which is actually given. And then the vertices we have for A, positive, negative, 120, 0. And for our co-vertices, we now have 0, positive, negative, 50. And for the last one, determine the standard form of equation of the hyperbola. Since our transverse axis lies on the x-axis, we can have our formula as x squared over a squared minus y squared over b squared. So that we're going to have x squared over a squared. We have solved a squared to be 1,000 or 14,400 plus or minus y squared over 25,000, 2,500 rather. 2,500 equals 1. So that is already our equation.